Okay, so today I'm going to teach you how to do number 12 on page 109 from chapter 3. So the question is, two forces are applied to a car in an effort to move it, as shown in the picture below. I recopied the picture from the book right here. A, what is the resultant of these two forces? And B, if the car has a mass of 3,000 kilograms, what acceleration does it have? Ignore friction. So in our picture, we have a red car here, and it's being pulled by two forces. So one force is 400 newtons and the other force is 450 newtons, and they're both at angles. So this force is at a 30-degree angle and this force is at a 10-degree angle. So to answer this question, what is the resultant of these two forces? We need to look at our forces as vectors. So to find the vectors of these two forces, since they're going at angles, 10 degrees and 30 degrees, we need to find the x and y components for each vector. So I already drew triangles over here. So for, let's say this is our force of 450 newtons, and we're going to call it R just to clarify while we're doing work. So the angle, as we can see from our diagram, is 10 degrees, and up here it'll be 450 times sine 10 degrees, and down here will be 450 times cosine 10 degrees. And for this triangle, it's the force of 400 newtons, and we're going to call it S for clarifying sake while we're doing our work. So it has a 30-degree angle, and these are also both right angles. And up here will be 400 sine 30, and right here will be 400 cosine 30. So now that we found our x and y components, we can start to solve the question. So this is going to be A, and first we're going to find R. So R equals, we put the x and y components, so the x component is 450 sine 10, and the y component is 450 cosine 10. And for S, the x component is 400 sine 30, and the y component is 400 cosine 30. So now we just have to simply put these into our calculator. So if you put them in, you should get negative 78.14 newtons, and this is negative because the x component, if we have our typical positive y going up, positive x going to the side, this x is going backwards, so that'll make our force negative. And then the y is 443.16 newtons once you do it in the calculator. And for S, we get 200 newtons and 346.41 newtons from calculating these and putting them into our calculator. So this is what we end up with. And so to find the resultant of the two forces, we have to add them together. So R plus S will equal negative 78.14 newtons plus 200 newtons. That's the x component. And for the y component, 443.16 newtons plus 346.41 newtons. And I'm getting these. This is the x component here. This is the x component for S. This is the y component for R, and this is the y component for S. So you need to just add these all together. So when we do that, we get 121.86 newtons and 789.57 newtons. So that's our resultant vector, but we have to find the magnitude of the vector. So to find the magnitude of our vector, we use our formula, the square root of the x component plus the square of our y component. And if you put all of that into your calculator, you should end up with 799 newtons. So that is the resultant of the two forces. So now, moving on to part B, if the car has a mass of 3,000 kilograms, what acceleration does it have? Ignore friction. So, to solve this, we have to, so it says that we have 300 kilograms. So our car here weighs 3,000 kilograms. And to find the acceleration, we have to use our equation of the sum of all the forces equals the mass times acceleration. So we just found the sum of all of our forces, 799 newtons, because it's the sum of these two forces. So that's the sum, and then the mass they just gave us, 3,000 kilograms, times the acceleration. And so now you just solve for acceleration. And if you put it into your calculator, you should end up with 0.26 meters per second squared. So for question A, you should get 799 newtons, and for question B, the car has an acceleration of 0.26 meters per second.